So this is going to be a tutorial on some of the tools that you need for cutting. Now, in my previous video, which I'll link down below, I actually go through kind of designing a plane, getting it on paper and print it out. So if you have any questions about things I talked about in the previous video, go check it out below. So some of the tools needed for cutting. This is not me saying that this is the best way. There's lots of other ways to do this. This is how I'm doing it right now. The tools that I have selected are for convenience, safety, and noise, and just pollution in general. I build my planes a lot of times in the house, right on the other side of the walls of my family, so it can't be loud, can't be making a lot of fumes, smells, dirty, things that are dangerous. So for instance, one of the tools that I choose to use for my templates is some aluminum flashing. It is flimsy, but it's very easy to cut with just scissors. No power tool needed. Now, if you wanted the best material, for instance, probably cutting it out of wood would make a longer lasting, more rigid one. So that would be, you know, the best material. But for me, it's noise and convenience. So again, these are the tools that I use, and lots of other people use other tools. So let's just get right into it. Let's start off with templates. So, you know, eventually the goal is to cut out a wing out of foam. And so you're going to need some type of template that is going to go on there that your hot wire is going to trace. So the material that you need has to be rigid, has to have a lot of pressure as the wire pushes down on it. It needs to be non-melting, obviously, because you're going to have some pretty hot wire. It would burn your fingers. I haven't measured it, but it's very hot. Now, the material I'm using is aluminum flashing from Home Depot. Comes in, you know, like this. Pretty flimsy, very thin. Now, in this direction, no rigidity at all. But in this direction, it's very rigid. And so when this is then pinned to a piece of foam with a bunch of holes, you can see even in this one, I have quite a few holes. I can put some pretty good pressure on there. So it could be plastic that isn't going to melt as you go over it, anything. So I'm using aluminum. Also, what I do first, as I showed in the last video, is I print my templates out on paper, and then I Super 77 it down to 2 sheets of this aluminum, and then I cut it out with scissors, and I'll go over scissors in a minute. But first thing you need is a template, and I'm using aluminum flashing. Then you need something to go and hold that in. I have just a whole bunch of these, I don't know what it is, 1.5 inch T-pins. I've seen people use screws. Anything that has a head on it that you can push through, and it's going to keep it in the foam and not move around with some pressure pulled on it. Now let's talk scissors. When I first started, I had these 10 snips, and I was like, oh, 10 snips? I mean, aluminum, that sounds like it'd be perfect match. But the thing is that I'm going to throw some B-roll up there that's going to really show a close-up of this. But since this is so short, every time you stop, it's going to create a little spot that is either low or high. And what happens is as your wire comes across that, it's going to catch, either because it's high or it gets down in a groove. And I mean, you can mitigate that by taking something over it and smoothing that out, or maybe sanding it. But do yourself a favor and use the longest pair of scissors that you have. And that way, that's going to be, you're only going to have a bump every, 3 inches instead of every 1/2 or 1/4 inch from using some small scissors. So regular office scissors, super easy, really fast, convenient. Now let's talk about foam. Again, the foam that I use in all of my videos is, I don't know if it's XPS or EPS, but it's a, it's like a white styrofoam. EPP would be the foam of choice, but there's a reason why I use Home Depot foam over it. EPP is a non-crushing foam. As you'll see in my demonstration of hitting it with a hammer compared to hitting this solid in-wall insulation foam. This stuff, when you have a hard crash, it has a tend to explode, popcorn, as we've seen styrofoam do, whereas EPP has a nice clean break. When EPP squishes, it bounces right back. And if it, like I said, if it does break, it makes a very clean cut it perfectly matches itself, and you can't even tell where it was when you glue it. And it's glued now, so now it's even stronger than it was before. But here is the main reason why I'm using this over EPP. Mainly it comes down to availability and cost. To get a 4-foot by 8-foot sheet, 2 inches thick, I just run down to my local Home Depot or Lowe's, $20. It comes out to 60 cents a foot, and whatever, 20 minutes and to get it, and whatever gas, a few miles. So EPP, it comes out to around $4 a foot. So that's, you're getting up there 6-8 times the cost more. Plus you can't buy it locally, and you're going to be spending another $20 or $30 on shipping, and it comes in a much smaller sheets. So you're right there, you're limited, or you have to start gluing stuff together if you have like a really big project. Let's talk about power sources now. The one that I use, again, is just because it was one of the first things I tried. I watched Andrew Newton's videos early on. At that time, he was using a 4S battery. I tried 3S, I tried 4S, I liked 4S the best, and it actually just works for me. Any 4S battery, even on my huge 90 wing where I've got, I don't know, maybe 80 or 90 inches of fishing wire that I'm clamping onto, it's pulling 3 amps on 4S. So I don't even put an alarm on my battery. I don't really, I plug it in and it's gonna last probably an hour nonstop, and you're not cutting for an hour. So as long as you remember to unplug it when you're done, no problem. Andrew has now moved on to an adjustable power supply. That works if you have it. A lot of people have that on their workbench. My reactor battery charger from Hobby King, it has a setting. I use that sometimes for doing small little cutouts for servos and stuff. I also have this kind of weird contraption I have here, which it's basically a doorbell transformer. A light bulb, so I know when this is on. It's kind of a safety feature. A dimmer switch, so I can adjust the power going to it, which affects the power coming out. An on-off master switch, and this is how I plug in my wiring harness. You basically need to apply a voltage to the wire in some way. And like I said, for convenience, I just find it really easy. I just plug this in and start cutting, and I'll show you my rig for turning it on and off. Now let's talk about wire. The stuff that I'm using is steel fishing wire. Again, recommendation from Andrew on his website. I don't think it's the same exact brand, but you're not going to find this at just a lake or river fishing store. This is 90-pound test steel wire, 7-strand. I have to order online because this is mainly an ocean, a pretty big fish type wire. On Amazon, this 30 feet costs $10. Pretty cheap. I've got 2 rigs made from this. I still have a whole bunch, so that's really great. I've also seen some people use nichrome wire, which is a much stiffer, solid piece of wire. Guitar strings, it's something you could look up and just try. Basically, you want something that will take voltage and become a load. That means it'll heat up. You do have to be careful. Even though this is steel, you can't apply too much voltage and it actually will crisp it. It'll destroy it. Now, you definitely want 90-pound or higher test, because when you're pulling on this wire, you're pulling on it hard, really hard. You don't want that to snap and fall back and hurt yourself. So let's talk about how to apply voltage to your wire. There's lots of different ways you could do this again. I'll just show you my simple rig. I picked up from Amazon. It's just a pack of various alligator clips. Pretty cheap. I then soldered that to some wire, and these clip on each end of my cutting area. I basically put my foam down that I'm gonna cut and then figure out the farthest points, you know, try and get as close as I can. On the positive side, I don't know if it matters, you can put it on either side. I have put an inline light switch. And so basically I plug in my battery to this and get everything ready. And then I get in my position, flip it on, do my cutting. I can unflip it. That way I'm not playing around trying to plug this in and unplugging it and stuff. And then another, one thing I did is I keep the positive side close to me so I can have this. So I made the negative side, the long side, so we can get down to the other side of the table. This is just something that I made up. Basically you have the cutting end. On this end, there's some big rubber band that basically is creating pressure so that this wire is always staying tight. It does, you know, you get pulling a lot of pressure on it. And then I permanently installed the alligator clips, and here's the little plug. And so I'll plug a battery into here and I'll just hold that. I use a smaller battery usually, but I'll hold it like this and then cut. Now, the times when you would use a cutting bow, myself personally, is when I'm building a center section or a standard straight wing where there's no taper or sweep or anything. It's just a flat, you know, standard flight test straight wing. Or a center section where the cord on each wingtip is exactly the same. It's a perfect rectangle. And so in that case, what I'll do is, that's why I cut out two of these. I'll put these on both sides of the foam and then basically take that and just trace that shape in the foam. It gives me a nice, perfect rectangular shape in the shape of an airfoil. Now, pivot point cutting is the way that I cut anything with the taper, where the center cord, the root cord, the middle of the wing is a different size than the end of the wing. And this is generally what you would see in a flying wing, where you have a center cord and it tapers down like that. They call it pivot point because one side of your wire is locked into a position and it does not move. And then you're on the other side of the table and that's the side that's moving, and it's pivoting on that central point that you've locked down. I've done it really simple and just put it on a C, like a C-clamp that I put on the end of my table. That makes it very mobile. I've used just a block of wood as my handle. I've used an extra piece of carbon fiber tube with some rubber grommets, something that you can hold on to, and the other end is going to take that pressure and not pop off. Now, there is a difference in the length of wire that you need. As you saw there, that bow was only about 28 inches. So that's 28 inches. That's as wide of a section that I can cut. Whereas when you're doing a cutting bow, a pivot point, you're more limited from how far you can get away from that pivot point. And so if you have a temporary setup, you could do it in your garage, and you could put your pivot point against a wall, and then the surface that you're cutting could be as far back, you know, as your wire is. So you could definitely make a huge bow, but for doing really long tapered wings, the pivot point is nice. And then, you know, you just wind up the wire and you put it in a box when you're done. Now, safety is an important consideration. There is some debate online about whether this type of cutting is dangerous or not. So the arguments are kind of like if you actually are heating up the phone hot enough, burning it, it's actually turning into a gas that you can then breathe in. Some people argue that hot wire cutting is, you know, melting, and that is not gassing off. It's not getting that hot. Some people say it is. I don't know. If you're going to be doing this regularly like I am, it's better to be safe. So let's just talk about some of my setup that I have. I have an exhaust fan, pretty high powered for my shop, and it is away from my face on the other side. So if I'm cutting in the materials here, the fan's over there, and I open up doors behind me, and I have a little fan blowing air across my face. And so I'm basically creating a wind tunnel coming from behind me, past me, out the door. And just like your oven fans at home, it takes a few minutes for the airflow to create the airflow and to change the airflow. So just like at home, before you start cooking, if you want some good airflow, you should turn your fan on at least 5 minutes before. I just get my air stuff going the first thing, and then I set up all my stuff. And so, you know, the idea then is that this is blowing past me. The wind's never coming towards my face. And then I usually let that keep running 5 or 10 minutes. And I actually just open up all the windows when I'm done. I make sure that my whole office airs out. So, you know, it's just better to be safe. Do it outside. If you do it in your garage, make sure you got some wind going or a fan or something. Now, let's talk about weights. I put a lot of weights on it so it doesn't move. But it's very important that anywhere that you have a weight, you have it fully supported underneath. I talked about having a piece of waste foam on the bottom. If you're using small chunks of waste foam, make sure that they are underneath every piece of every weight that you have, because if you don't, what'll happen is if it's not supported and you have weight, it'll actually bend. I'm exaggerating here, but it'll bend and you'll get this, it'll look funky. It's not going to work. That then is, you know, all the parts that I use. A lot of this stuff is really cheap. And then, like, for instance, I bought this a long time ago. I've done like 4 or 5 planes, and even, I mean, you can see, this is my 90 inch. This is the biggest thing I'm ever going to cut. And I mean, you could almost get 3 of those. So this, you know, I'll put links below to all these parts, but a lot of this stuff you may even have fishing line, T-pins. You might find some aluminum or wood around your house that you can use. And even if you have to buy something, this is stuff that's you're just going to have it then for a really long time. I'm never going to have to buy this again. T-pins don't go bad. Fishing line I've had to buy twice, so I've spent $20 just because I made a stupid mistake cutting it too short or something, or I gave some to a friend. But again, a lot of this stuff you could probably come up with a way to do it in your shop. Now in the next video, I'm actually going to get into the actual kind of geometry of setting it up on your table. I'm going to get into some things that I've learned from making mistakes. I've cut a 60-inch wing, a 90, a Cap 232, big Bronco plane I'm cutting, but in doing that, I've cut a lot of cores out that didn't work. And then also in showing my friend, he made a mistake that I'd never just randomly didn't happen to me, but now we know why it happened. So I'm going to go over some of the geometry of the wires and how much pressure and all that stuff. So, but think of this more as like an art. It's something that, you know, you're not going to have the exact same stuff I have. It's something, even with me showing you, you're going to have to play with it. And again, this is just my way of doing it. I'll try and link some stuff below to other people that do it, and definitely go though out there and try it. I kind of mentioned how cheap this foam is. Just for instance, my 90-inch wing, that used a good portion of half of one of these sheets, but I have tons of cutoffs I can use for other projects. So my 90-inch wing is, I say it's a $10 plane. I mean, obviously there's more stuff into it, kite rods and tape and that kind of stuff, but $10 worth of foam, and the cutoffs I could use to make a bunch of little planes. My 60-inch wing that I cut, $5 worth of foam. My Cap 232, $5 worth of foam. So this is something that you can buy and make mistakes and learn, and it's not going to cost a lot. So go out there and try it. Let me know. I'm sharing this because everything I've learned for free from people online. So go ahead and try it, and I'd be happy to see the things that you guys do with it.